Okay, hello and welcome to everyone tuning in today to our battery charging fundamentals webinar presented by Delta Q Technologies and Discover Battery Solutions. I'm Paul Drabble, Senior Marketing Manager at Delta Q, and I'll be moderating today's session. So for the agenda today, our presentation time is approximately 40 minutes. We'll have questions, so please submit those using the Q&A feature in the Zoom webinar control bar. And your questions will be submitted anonymously and will be answered at the end of the presentation in the order that they're received. If you have any tech issues, please send those through the chat button on the toolbar. So the three takeaways from this webinar. Firstly, to understand the current battery technologies and the fundamentals of battery charging. And finally, which batteries and chargers are right for your application. So about our speakers today, we have Hiroshi Hasegawa and Jimmy All. So Hiroshi is the Customer Success Manager at Delta Q Technologies, has 15 years of experience in various roles in product support for OEMs, including services and account management. He has a PhD in electrical engineering. Jimmy comes to us from Discover Battery. He's the Vice President of Business and Product there. He has 15 years of experience with customer support and product account management, business development in the area of AGM and gel battery product management in the areas of area work platforms, floor care, and distribution. In terms of the two companies, Discover Battery started as a battery distributor in 1949, is now a leading manufacturer on a global level of award-winning lead acid and lithium power solutions. Delta Q is an advanced manufacturer of lead acid and lithium ion battery chargers, and we supply tier 1 OEM manufacturers of industrial recreational electric vehicles. And we're also a member of the Zappi group of global companies, which specialize in electrification solutions for industrial and recreational vehicles. Discover Battery is a partner of the Charge by Delta Q program. We'll talk about that right at the end. The Charge by Delta Q program is a program where Delta Q works with leading battery manufacturers to optimize their batteries with Delta Q chargers in terms of charging profiles and algorithms with the goal of optimizing battery life, performance, and uptime. So the benefits of that is that our customers can fast track their time to market by being able to choose optimal battery charger pairings for their application. Okay, now I'm going to hand off to Jimmy to get into the webinar and talk about battery basics. There you go, Jimmy.
Thanks, Paul. I'd like to thank Delta Q for inviting us onto this webinar today. We'll jump right in and take a quick glance at what a battery is and some of the technologies that are available for your battery-operated equipment. The first portion into battery basics will be quick. We'll probably be spending majority of the time towards the end where we review real-life examples of how batteries and chargers are installed into different types of equipment. So we'll be learning a little bit about the types of batteries here, how they work, and the distinctive behaviors. Next slide. So for those that aren't too familiar, what is a battery? A battery is a device that stores energy in the form of a chemical potential energy. The chemicals within the battery react to produce electricity when a circuit is complete. A battery is a portable power device. It can be used to power a wide range of equipment. Batteries are manufactured for different types of use and purposes. So some common ones would be starting, which is the batteries you use to start your vehicles. Standby use, which are batteries for UPS purposes, backup power. Deep cycle use would refer to batteries that are used to power the loads in your boats or in your campers. And then traction use, which in North America would be termed as a heavy deep cycle. So mostly industrial battery operated equipment. So we refer to that as traction use. And today we'll be more focused on this specific category. A battery is measured in voltage and amp hour. So voltage refers to electrical pressure and amp hours refers to the amount of energy the battery can deliver. When you put the two together, you have power, which is needed to calculate how long your equipment can run for. Next, please. So within motive applications, there are two main battery categories to focus on. One is lithium and the other is lead acid. Within lead acid, you have three subcategories. And within these three subcategories, as you can see here, you have a flooded battery on the left, you have an AGM and gel. The largest differentiator amongst the three technologies is the form electrolyte takes. Electrolyte is essentially a mixture of water and acid. So it is corrosive and it is hazardous. And if you are touching it or whatnot, it's important to clean and be careful, as it is, like I said, hazardous and corrosive. So the technologies that you look at here, main differentiator is some is maintenance free, some aren't. So if you look at a flooded battery, electrolyte is free flowing, so it's in liquid form. You see caps at the top where you have to twist open and top up with water as you cycle the batteries. And as the batteries age, you may have to top it up with water more frequently. On the middle and on towards the right, you have AGM and gel. They're also known as valve regulated lead acid, or SLA, which is sealed lead acid batteries, depending on which region you're based in. Both batteries are maintenance-free and non-spillable. They're non-spillable because there is no free-flowing electrolyte like you would see from a flooded battery. With an AGM battery, the electrolyte is what we call suspended. So the electrolyte is absorbed in the glass mat material. So no free-flowing liquid. On the gel end, it's not suspended, but rather the electrolyte is immobilized. So it's gel-like, which is why it's called a gel battery. So these are the three essential and most common lead acid batteries used in motive equipment. Next slide. And then quickly onto lithium batteries. With lithium batteries, most of you may already know the obvious benefits to lead acid. These general benefits would include the batteries lasting longer and being able to deliver more runtime. The lithium batteries are typically much lighter than you would see out of a lead acid battery, and it has the capability to accept a higher charge current, which allows you to dramatically reduce charging times when compared to lead acid. Though there are many advantages being boasted about, I'd like to also mention that lithium is not for everyone and it is not for everything. There are a number of cases where you will find that if you do the proper research, the implications of using lithium outweighs the benefits it can bring. And we will cover more of this towards the end with some actual examples. Moving on to the bottom portion of this slide. We break it down into what we call smart versus standard lithium. And it really comes down to the capability of the BMS, the battery management system. Generally speaking, the higher end BMS allows for better communication or more communication across devices. And across devices refers to the batteries being able to communicate with one another within the system, the batteries being able to communicate with the charger for potentially faster charging, and even the equipment and the operator, or how the batteries are behaving. This is usually done through CAN. The more standard lithium batteries in the market today offer little to no communication. If it does offer communication, it's generally to the user or the operator, and this is in the form of a simple Bluetooth app. Other thing to highlight would be smart lithium batteries tend to also have more protection designed into it to prevent premature failures or damage done to the batteries when used in the field. It is also usually able to handle higher discharge and charge currents reliably and safely when compared to standard lithium batteries that may not have these type of protections. You might see other bells and whistles with the smart lithium compared to standard lithium batteries, and this may include heating for low temperature charging, as well as some batteries have ease of service. So when deployed in the field, if you have to troubleshoot, you don't have to just replace the entire battery, but maybe you can change out the fuse. So less headaches and faster troubleshooting. If you look at the two images here, what we have at the top there is the smart lithium, our DLP, and then at the bottom there is our Bluetooth lithium, which is what we refer to as the standard lithium. Next slide, please. So this one here is a comparison chart across the four technologies I briefly spoke about. The information is actually available on our website. So without going into too much detail line by line, I just want to talk about the economics across the four. And you can see it in the last two rows on this chart. So with a flooded battery, the cost to produce a flooded battery is lower compared to the rest of the other technologies, and therefore the initial cost is the lowest. But if you factor in and look at total cost of ownership, the associated costs with the labor, the time required to top up with water and check the water levels with a flooded battery, the need for equalization, cleaning the terminals because of potential corrosion due to off-gassing, those are all costs associated that you do not see upfront. And therefore, total cost of ownership tends to be higher for flooded batteries. And then the other side of the spectrum, as we all know, would be what we call lithium. So lithium initial cost is highest, total cost of ownership is lowest. And the reason why total cost of ownership is lowest with lithium is, number one, the nature of the chemistry to allow for longer run times, more cycle life, and also the help of the electronics to protect the lithium cells from being damaged by the environment or the user when operating outside of its design parameters. AGM and gel, I call it kind of the best of two worlds. It's the two in between. So in terms of initial cost, it's not the cheapest, but it's not the most expensive either. It still is a maintenance free, so you don't have to deal with any corrosive electrolyte substances. The total cost of ownership is also in between. So it's still a bit more expensive than lead acid, but still much cheaper than lithium. Next slide. This one here gives you a better picture of, again, a comparison, the different technologies, but in the same form factor. So the group size you see here is what we call a GC2 size. You will recognize this and find it common in places like golf carts, scissor lifts, electric scissor lifts, pallet walkies, floor scrubbers. So generally it's a 24-volt system and you might see 4 of them. If you look at the lead acid family, which is the flooded, AGM, and gel, they're all 6 volts in this case. Amp hour wise, they're all more or less the same as well. They range from 200 amp hours up to 225 amp hours. That's how much capacity you can pack in this form factor. You will see gel batteries are a little bit lower, really just because of the nature of the chemistry, but you will get a little bit more life out of it compared to the other technologies. I've also included the 5-hour rating for the audience that are watching from Europe. The 5-hour rating refers to a higher discharge current, and the capacities across the technologies could range from 180 to 170 amp hours. Jumping onto lithium, with a lithium battery in the same group size, I have here shown a 24-volt, but it's not uncommon in the marketplace to see 12-volt batteries, 36-volt, and 48-volt in this same form factor. With the 24-volt, you can generally pack in about 60 amp hours of capacity. What's interesting across lithium compared to lead is you can see with the lead acid, it's generally 28 kilos or around 60 pounds, but lithium is half the weight, so 30 pounds or so. If you start thinking about the entire system in your scrubber, in your pallet walkie, or in your golf cart, you need 24-volt system, 48 if it's golf. But if we speak specifically on 24-volt systems, you would be putting 4 of these lead acid batteries in series. The capacity would then remain the same, 225 to 200 amp hour C20, 180 to 170 amp hours C5. Looking into lithium, you have probably the option, depending on the specific application and the discharge currents, to install between 3 to 4 batteries in parallel, not in series, but in parallel of these 24 volts. So in terms of capacity, because these are 60 amp hour batteries, 3 of them would take you up to 180, and then 4 of them would take you up to 240. So you would way surpass lead acid capacities. Weight as well, you can see there's a huge advantage, at least half the weight as lead acid. With a lead acid set up in 24-volt systems, you would be looking at close to 250 pounds or 115 kilos or so, versus with a lithium, you're looking at a total of around 40 kilos or 92 pounds for 3 batteries in parallel, or 56 kilos or 125 pounds with 4 batteries in parallel. Moving on. This is for Hiroshi.
Thanks, Jimmy. So when it comes to a battery, you can think of it sort of like a bucket, almost. The charger adds energy into the bucket, and the load draws the energy out of the bucket. But there's holes in the bucket. There's energy losses. You lose stored energy due to different factors, such as self-discharge, battery inefficiencies, and the effects of current and temperature. These holes, the size of these holes depends on a lot of factors, including the battery chemistry. For lead acid, the holes are quite large, and for something like lithium, they're quite small. So I'll just kind of go over the first hole is self-discharge. All batteries by their nature self-discharge. Some discharge faster than others, like a flooded lead acid, or lithium, something without an on and off switch that's constantly drained would drain faster. Round trip efficiency. And another hole in the bucket is the battery efficiency, which spans from between 70 to 90%, with lithium being more efficient and things like lead acid being less efficient. And this is due to factors such as internal resistance, temperature, and the nature of the chemistry of each battery. The discharge currents. There's a phenomenon with lead acid batteries called the Pukert effect, and that means the higher you drain with your charge current, the less overall capacity you get. Whereas lithium, there's no Pukert effect, but the discharges are strictly controlled. The currents are controlled by your BMS. The temperature effects. Low temperature results in less overall capacity, but better overall life of the battery. Whereas high temperatures, you can extract more capacity out of a battery with the trade-off of having less overall battery life. Some technologies are more sensitive than others. Lead acid is generally more forgiving with a wider operating and charging temperature. Lithium doesn't do well in extreme temperatures, and the BMS tends to restrict charging below 0 degrees Celsius. So overcharge and discharge. Lead acid batteries technologies have improved and are generally more forgiving when overcharge and discharge from time to time. Some chemistries are more forgiving than others. Flooded and gel tend to be more forgiving, whereas lithium charging behavior is generally restricted by the BMS just for safety purposes. So next slide. So we'll get into a little bit about charging and the type of battery chargers in this next section. Next slide. So just a definition from Wikipedia that everybody can read. The definition that we like to use, which I think is a little bit better, is a charger supplies electrical energy in the form of charge that a battery stores, as Jimmy alluded to, as a chemical reaction. It uses electric potential to move ions within the battery cell. Next slide. So charging lead acid batteries. Whenever there's a transfer of energy, there's always some losses. Nothing's 100% efficient. Lead acid batteries require overcharge to maintain a long-term battery health. And overcharge results in restoring lost energy, and it also provides a gentle finish for plate recovery to keep them healthy. The methods that we use to achieve overcharge is either a precise overcharge measurement, or what we call DVDT, which is basically looking for a change in the overall voltage of the battery. Now, overcharge is different from equalization, which is a term you hear a lot in batteries when you're talking about batteries. In theory, just the right amount of overcharge on every charge will minimize the effect of equalization, which can only be done when the electrolyte is accessible, like a flat lead acid battery. Next. So there are many different ways to charge a battery. The most common methodology is what we call IU, or constant current, constant voltage. So some people nickname it float style charge. You see this approach in stationary applications such as battery backup, or off-grid applications such as solar battery storage. The float battery may also be slightly lowered if it is permanently kept on float. Although simple, the IU charge profile can take a very, very long time. And if it's left unattended, one of the downsides is the IU charging can dry out a battery over the course of weeks. One method to prevent and remedy this is to make sure that you're using the correct amount of charge. For most motive applications, are cyclical, meaning the battery is drained and charged over and over. For cyclical application, we shorten the float phase by returning a constant voltage, a constant current, and calculating a certain amount of overcharge. This method of charges we refer to as IUI, constant current, constant voltage, and then constant current. This minimizes charge time and provides the best overall performance. At Delta Q, most of the charge profiles that we do for lead acid and lithium batteries, or for lead acid batteries, is IUI. Next slide. An IU profile is typically what a lead acid or a lithium battery uses, and can be either delivered by the charger using some sort of preset algorithm, but the best and most recommended method is for the battery's BMS to control the charge. Next slide. So we'll just have a brief history of the different charger technologies. The analogy that we like to use is a battery and charger combination is much like a horse and carriage. Next slide. There's two main types of chargers that you'll see in the marketplace. Low frequency, such as ferroresonant or SCRs, and high frequencies or switch mode chargers. Ferroresonant chargers have been around for a very, very long time and are still in service basically due to their simplicity. They use a transformer to control the charge with a timer or monitor circuit, and this simplicity also means that they're big and heavy, not particularly efficient and not particularly precise. However, they do tend to be easy to service, though they may need frequent service if exposed to extreme conditions. There's an example of the unit shown above. Typically, ferroresonant chargers apply low current for a long period of time in a single charge, constant current. An evolution of the ferroresonant charger is the silicone-controlled rectifier, or SCR charger. It adds some electronics to help control the output of the big, heavy transformer, which is slightly smaller than the ferroresonant. The electronic controls make charging a bit faster and more precise, but this comes at a cost as the charger becomes less efficient and the electronics can be vulnerable to the environment. So for the past 20 years, we've seen a big shift in power supply technology toward high frequency, or what we call switch mode power supplies. You've noticed that how much smaller and lighter your cell phone or application power supplies have become compared to the giant wall warts that you used to have a few years ago. The charger industry has seen some similar shifts to high frequency, which refers to the switching speed of the transformer inside. A microprocessor controls the transistor at a high switching speed so that the transformer and thus the charger can be much smaller and much more efficient. However, with any new technology, high-frequency chargers have gone through some teething in reliability due to their complexity. But at Delta Q, we feel that we've solved these reliability issues with our charger offerings. Next slide. So when it comes to selecting a charger and batteries, all the components must match in voltage with the battery within the battery pack. Power electronics are optimized for certain voltage ranges. The nominal voltage of a system will be dictated by factors such as power and performance requirements. And as with everything, there are trade-offs. Higher voltage equals lower current and smaller conductors required, but maybe safety requirements become much tighter. In most of our applications, the voltage ranges from 24 to 48 volts, although there are some higher voltage applications that you'll start to see. An example is in construction, where the sides of the loads get really large and the move is to higher EV level voltage ranges, typically above 300 volts. So next slide. And we'll get into the case studies that Jimmy and I will cover.
Great, thanks, Roshi. So we picked a couple applications from around the world. There's about 5 of them that we're going to share and talk about why this specific battery was used and what the other alternatives would be if we used another battery, and what type of charger would be appropriate in these type of applications. So the first one here, what you see is a ride-on order picker. These are commonly used in North America and Europe. It's a type of a warehouse vehicle used to improve worker productivity and safety. These vehicles need to navigate through narrow aisles, and the operators are required to lift up and down to pick up, place, and retrieve items off high shelves. In this particular setup, you can see the batteries are actually installed on its side and it's not upright. So the ideal choice, as you can see here, would be AGM. As we mentioned earlier, AGM batteries, the electrolyte is not free flowing. It's not in liquid form, but rather suspended and absorbed in the glass mat material. So it's maintenance free, non-spillable, and fully sealed. If you use a flooded battery, there's potential for spillages. If that's not an issue, even the requirement to top up with water is impossible because of the orientation as well as how tight the compartment is. If we're thinking about how we can get more productivity out of this ride-on order picker, lithium could be a potential good fit, but it's important also to understand not just on the battery front or the charger front, but the integration and the use of this piece of equipment. So as an example, if these order pickers are used hard during the day, it's used on and off basis. Lithium is a bit more forgiving than lead acid technologies under partial state of charge operation. So this could be a potential good fit if that's the case. If it's required to be used and discharged down all the way to, let's say, 80 to 100% DOD, or what we call depth of discharge, lithium, again, could be a good fit because within the same form factor that you see here, lithium can pack in more capacity or runtime. And it's also able to deliver with the proper BMS in these lithium batteries, a faster charging time. And that's given that there is a higher output charge source in the warehouse. So knowing the charger output and the sources available is important to get the fast charge you need for lithium. Otherwise, it's not that big of an impact. But on the other side of the spectrum, there are other considerations. When looking at this and looking at the application, I would think about, is it field serviceable? If there are issues with these lithium batteries, how hard would it be to troubleshoot? And how hard would it be to get the machine up and running again? Lead acid batteries compared to lithium overall are generally easier to troubleshoot, and it is easier to replace if worst comes to worst, you identify there's a defect or there's some sort of fault with the batteries. Versus with the lithium battery, replacements might be a little bit harder, it's more expensive, and the logistics of it is a little bit more restricted than a lead acid because of its hazmat requirements. The other thing I would look at here is potentially in material handling. A lot of lead acid batteries are used for counterweight, and it's a safety issue when the batteries are lighter than spec. So when you install a lithium battery that could be up to twice less in weight, it could be a potential safety concern. So you may not want to swap out lead acid batteries with lithium before understanding from the OEM and from the manufacturer what is possible and what the options are. It's always nice to have the integration done at the OEM level. This picture here is a 24-volt system. It's got 4 6-volt batteries in series. So the total system is a 24-volt, 230 amp hour application. On to you, Hiroshi.
Yeah, one of the things I just wanted to mention in this application is that there's a number of different chargers that can be used, but we feel that the Delta Q is a good choice in this application because it has a feature we call temperature compensation, which is measuring the overall temperature of the batteries, which is ideal. Jimmy and Discover can talk about how they recommend having temperature compensation control when charging sealed batteries, just so that you get that precise overcharge. So that's one of the features and benefits, as well as being small and compact that could fit in a tight application like this.
So yeah, adding on to that, Hiroshi, is like as I went on in the early beginning, talking about the different technologies. So the disadvantage with flooded battery is the need to top up with water, but it's also more forgiving in that sense because you can somewhat reverse the effects If you overcharge, over discharge, you can still somewhat add water back in and be up and running again. Is it going to be back to 100% health? No, because it's damaged, but it still will work and it still will do the job relatively well. With an AGM or gel, because it's fully sealed, you will not be able to reverse the effects. So having temperature compensation and the proper charging algorithm is critical to get the longevity out of the batteries that it's designed for. Anything else you want to add here, Hiroshi, or should we move on to the next?
No, we'll go to the next one.
Okay, so the next one, please. This one here, you can see is an autonomous floor scrubber. It's becoming more and more common in the floor care industry. And if you travel, you will often see these more and more in airports and in shopping malls just because of the amount of cleaning needed and the square footage required being cleaned. In this particular example, this is provided by our battery partner, TPS, the power source in Australia. The machine is utilizing dry cell AGMs due to its reliability, non-spill, and maintenance-free benefits. The autonomous scrubber, you can see, has 8 of our 6-volt, 260 amp hour C20 batteries connected together in series to form a 36-volt system. As I mentioned earlier on this about these robots, productivity is key and is important. And we do have customers coming to us and operators asking about more productivity and runtime out of it. But careful consideration is required when thinking about what can be done, because it's not just about changing out the battery or the charger, but rather looking at the entire ecosystem before doing so. So a couple examples on this particular machine would be that was looked into as to improve runtime. Larger capacity batteries can be installed. We have batteries that are 330 amp hours compared to the current 250, but it would be taller and it would be quite a bit heavier in weight overall. And when you install these batteries to give more runtime, you end up damaging the wheels on the scrubber. Another one would be if you consider lithium technology, it could be a decent option because it's lighter in weight and it won't damage the wheels, like I said, for the heavier lead acid, higher capacity batteries. But in this machine, there are alarms and set points and telematics that are programmed for lead acid. So if you do a lithium swap, you would run into incompatibility issues and throw off the configurations. So this one here, I would recommend going back to the OEM, understanding what options are available for this specific machines and if there are any potential integration with alternatives other than lead acid. On to you, Hiroshi, on the charger bit.
Sure. So just getting back to what you said, so are you finding with lithium applications, they should be designed from the ground up, like at the OEM level from the start, rather than trying to retrofit them into a machine like this? Is that what you found in the past?
I think it's dependent on the application and the setup. If the machine is more sophisticated and it's got more kind of bells and whistles to it, in this case, the telematics and the alarms and set points, then yeah, it's best to go to the OEM to talk about how to improve runtime and get more productivity out of these machines. But there are other applications where if you find the right integrator to do the job in the aftermarket, it is possible. And people are doing this around the world already. So it's nothing new. There still is a learning curve, but certain regions around the world would be more advanced, let's say, than other regions or compared to other regions.
Right. So as far as the charger, this application uses an off-board IC1200 with a docking station. And when it comes to these autonomous floor cleaning machines, they can be super sophisticated that has some kind of robot automatically dock it. But I think in this case, Jimmy, a user still needs to plug it into the docking station at the end of the day, right?
Yeah. And I think it goes back to a docking station would be nice. But if you look at the entire ecosystem, which some of it, I don't know the nitty gritty details of it, but I would think about how big is the tank for the chemicals or for the water. If everything is autonomous, you still have to account for having an operator come over to change out the chemicals, the water, so on and so forth. So
Right.
A docking station would be nice, but you have to factor in all these other things along with it than just the
Right.
battery charger itself.
Right. That makes sense.
Yeah. So moving on to the next one, please. So now we're going from Australia over to Europe. The one we picked out here is it's a floor sweeper. And this is a ride-on floor sweeper in Europe that commonly comes with flooded or gel batteries. As you can see in the photo on the top right there, the battery compartment is easy to access. It's just right beneath the seat, so you can flip it up. So it's easy to access and open, and it makes water topping easy and convenient as well if you use and decide on flooded batteries. And if the operator is experienced with battery maintenance and water topping, then this solution, flooded batteries, is good enough and very economical. Otherwise, if you don't want to deal with the maintenance, gel would be more common in Europe, and AGM would then be used for the added runtime and capacity. Compared to a gel battery, as I mentioned earlier, you're with an AGM, you're getting about 15%, if not sometimes 20% more in runtime. So maintenance-free batteries is a good alternative to flooded as well, if that's an advantage to you or a benefit to you. I do want to mention, though, that when selecting battery technologies or choosing what chemistries to use, first make sure what you find out what charger is in the piece of equipment and understand what type of different settings are available in that specific charger. But generally speaking, industrial chargers nowadays are high frequency, as Hiroshi mentioned, and they would at least have what we call generic AGM, a generic gel, generic flooded, and maybe a lithium charge setting to choose from. There are other industrial chargers nowadays too that are more specific. So they narrow it down to not just the battery chemistry, but the battery brand, and in some cases, the specific battery models. So the more you can narrow it down, the better the user experience would be, because then the charge profile or the charge setting is further optimized for that specific battery that's in your equipment. This example here is actually provided by our partner TAB Benelux in Holland. So in this case, you can see on the left and at the bottom there, the images, they've been recommended are DLP lithium batteries. It's a modular design, and it's been selected for enhanced productivity over their existing lead acid setup in their sweepers. The lithium batteries weigh much less than a lead acid, so there's a huge weight savings. You can see that depending on the operational requirements of these sweepers, one sweeper can have 2 batteries, the other sweeper at the bottom can have 3 batteries, and it's got room for even 4 depending on how much the sweeper gets used. And there's also cost savings by having this modular setup. Not every sweeper needs as much runtime as all the other ones. So if you understand the ecosystem again and how it's being operated, you can also optimize the batteries inside. On top of that too, what's important, also what Hiroshi mentioned in one of the examples before, to ensure the lead acid to lithium conversion is smooth. Besides our partners providing the lithium battery as well as the chargers, they're also involved with the integration work. So all of the installations, the design work is done by TAB Benelux. They also have a recycling program for lithium batteries. So when the lithium batteries reach its operational or useful end of life, they are able to help the customer with the recycling side a bit of it. Another key point too would be this particular customer with the sweepers, they're located within their service area of our partners. So if there are any needs for troubleshooting or potential concerns, they can actually attend to it in a timely manner and quickly. What you can also see there, that circular gauge is a lithium specific gauge, and it's part of an example of the integration. If you stay with the existing lead acid battery gauge, you will not be able to see much, and there would be no accuracy at all using the lead acid battery gauge. You will need a lithium gauge for the user to see how much juice is left in the battery. On to you, Hiroshi, on the battery side.
Yeah, the only thing I'll add to this is the fact that this uses a IC 1200R. You can see in the top left corner, our IC 1200 with comms, and this is particularly advantageous because of the closed loop charging. The charger is directly able to communicate with the other systems in the application, which allows for faster and more precise charging, and allows feedback to things like the gauge that Jimmy just mentioned. So.
And adding on to that, like back to if the smart lithium batteries can talk to the charger, it's able to tell the charger how much energy or how fast or how high of a current, I would say, it can take. Our testing has shown that with closed loop charging, you can actually charge up to 40% faster because of the battery's ability to actually talk to the charger on how it wants to be charged. So this is something that lead acid cannot do for sure. And it's also one of the advantages that if you are thinking about lithium, these are the benefits that would give you kind of the bang for buck.
Right. Smart versus standard lithium batteries, right? Like you referred to earlier.
Yeah. Yeah. Okay. So that's Europe. And then on to the next one. So this one here, this is also a good one. We're still in Europe, but this is actually an electric mass lift. These mass lifts are produced in France, and as you can see, they're equipped with our maintenance-free dry cell AGM batteries, mainly to avoid water topping and to prevent off-gassing in such a small compartment space. You can see in this specific compartment, accessibility is not the best, so the benefits of not having to top up with water again and use a maintenance-free battery is extremely convenient. If you do end up using flooded batteries, that's a potential for electrolyte spillages, and to clean that would be very difficult. And as you know, within maintenance-free, we call it SLA or VRLA. You do have two choices, AGM and gel. But generally speaking, for mobile elevated work platforms, dry cell AGM batteries are preferred due to its ability to provide longer runtimes than a gel, and also because of the structure and the chemistry, its ability to handle high discharge currents over gel as well. So if you look at scissor lifts in general, or even boom lifts, aero work platforms, discharge currents when you're driving around could be low. However, when you're lifting up, most likely minimal. You'd be looking at least 200 amps when lifting up. So that is quite high for a deep cycle battery if you do it continuously. So in this particular example, this is from a rental yard, and it's equipped with our EVGC6s, 4 of them, to make your 24 volt. On to you, Hiroshi.
Yeah, you can see in this application how tight the spacing is, so there isn't a lot of room. So something like our IC650 would be ideal. It would be the right size to be able to charge. And because, as Jimmy alluded to, it's difficult to get access to these batteries, and they've used some kind of sealed battery, having temperature compensation to precisely charge these batteries is critical. So something like the Delta Q IC650 would be ideal because it has the ability to communicate and monitor those battery temperatures. So if you had used some other brand without temperature compensation, the life of the battery could be affected. Right, Jimmy?
Yeah, exactly. And to speak about that too is when these machines are being built in France, they're not just used in France. So these lifts are sold and distributed around the world. So when you talk about temperature compensation, it's extremely important because of just not knowing where the lifts would be deployed. And that definitely would optimize the life of the battery and give you a better user experience. Okay, so on to the next one. This one here is the more interesting one, I would say. We're now moving on to Asia in Japan. With this particular one, this is actually from about 6 years ago. This is a electric scissor lift. where in Japan, a majority of the work platforms there have already transitioned to mostly maintenance-free batteries due to the high appreciation for an emphasis on efficiency, organization, cleanliness, and tidiness in the region. So in this particular example, you can see at the top there, as standard, the machine is equipped with 4 6-volt batteries as standard. And then the photos at the bottom there are lithium batteries that was used as the experiment or trial. So our partner in Japan, Nisco Corporation, they were given a challenge by the Toyota factory to provide and try and give them more runtime in their lifts so that at the end of the day, these lifts can be driven outdoors for charging outside. At the time, we only had 40 amp hour lithium batteries. This was 6 years ago. So we had to put 4 batteries in parallel to form 160 amp hours. Overall, what happened? Well, runtime was about 10-15% higher than lead acid during the summer months. But coming winter, because lithium chemistry is more sensitive, the capacity or runtime was quite a bit less than lead acid. So in the end, this project was a no-go. And on top of that, because the whole purpose of them wanting to do all of this is to have charging done outdoors during wintertime, charging lithium batteries under low temperatures was a concern. If you look at what we have today or what's even out in the market today, there's batteries using our DLP as an example, the 24 volt. A 24 volt DLP GC2 battery would be 60 amp hours. If you have 4 of them, you would have a lot more amp hour than the current or the original lithium setup. So probably about 50% more capacity than the setup you see in these photos. If you think about the charging constraints under low temperature, the DLP lithium batteries have self-heating inside. So with the right charger, it can charge under low temp conditions. So this one is a good example of reminding everyone that even with lithium, understanding what the different lithium capabilities are for each different product, and if you can utilize some of the benefits and features, not all applications needs all the bells and whistles. The more bells and whistles you have, the more expensive it becomes. But if you understand how to use those benefits and features, then it becomes a worthwhile experience for the operator as well as for everyone that's making these conversions. Did you want to speak a little bit about the charger on for this application, Hiroshi?
Sure. I mean, Nisco's a great partner of Delta Q's, and they've selected to use the IC650 24 volt in this application, which is especially important, as Jimmy mentioned earlier, because it's an outdoor charging condition. So sealability and having a fully reliable sealed charger is going to be important in an application like this, whether it's lithium or some kind of sealed lead acid. So for us, I mean, having and also being outdoors and moving around, shock and vibe is pretty important, that we have a reliable charger that can take the rigors of being used in an outdoor environment. So
great. So I think that pretty much wraps up this example. With this slide here, just to share with everyone, if you haven't been to our website already, we do have some additional tools and resources that kind of repeats what we just talked about, but in more detail. We have a TCO calculator to help you really understand the benefits of going from a maintenance battery to maintenance free, and being able to help you calculate exactly how much you're going to be saving on an annual basis or over the entire life of the two technologies. And this is based on how you use the batteries. So it's quite dynamic in that sense. We also have application related content for scissor lifts, material handling, floor care. So you can also download the specific case studies relating to those applications for some additional learns. Next, please.
Okay, well, thanks, Jimmy and Hiroshi. Don't run away yet. We're going to get to the question time right after this slide, but just quickly speak again to the Charge by Delta Q program. The goal of this program, Delta Q validates its battery chargers with leading battery manufacturers to provide the optimal battery charger pairings so OEMs can fast track their application development. So some of our partners are listed at the bottom. There's more than what you see here. If you're fast enough, you can grab your phone and quickly scan the QR code and visit the information page on Delta Q. Otherwise, just go to Delta Q website and you'll find info on Charge by Delta Q right there. All right, so time for questions and answers. We've had quite a few questions submitted, so we'll get straight into them in terms of the order that they're received. So the first question is there a standard BMS communication protocol and message structure, or all are manufacturer dependent? If communication is not standardized, does a smart charger always need to be designed for a specific battery?
You want to start with this one, Jimmy? I think you're muted. There you
go. Oh, can you repeat that one, Paul?
Okay. Is there a standard BMS communication protocol and message structure? So is it standardized or is it manufacturer dependent? If it's not standardized,
I would say the most. Okay, got it. So I would say the most common one at the moment would be CAN communication, right, Hiroshi?
Correct. But there's, again, just like if you're a computer guy using Linux, right? There's different flavors. So there's different CAN flavors that there are. CAN open, 1939. There's different ones, but CAN is the standard protocol that most BMSs use, and that's because it needs to talk to other parts of the charging system, the motor controller, gauges. There's the different things. So by and large, it's CAN, but not always. There are some specialized versions that people self-make within their organization, and that leads to conflicts. But what we found is most of the manufacturers stick with some kind of CAN protocol because there's other equipment that they need to talk to. They're just not their own little island. So I don't know. What have you found in your Discover world, Jimmy?
Same thing, Hiroshi. Mostly CAN from the OEs we work with and the requests that we get.
Okay, next question. What's the difference between 1C cells and others?
Do you want to jump in, Hiroshi?
I think it's a battery world. It's more for you talking about discharge rates. So go ahead.
Yeah, so there are different chemistries that can deliver different current, high currents. 1C, half C, it really comes down to what you need for your application. The ones that can give you 1C or even 2C, let's say, means that it can actually deliver or take in provide a higher discharge current. So dependent on the type of battery and application, different cells could give you different outcomes, meaning you might need really, if you have a 2C battery or let's say a 3C battery that can deliver those type of currents, your battery, if you think of it, it could be much smaller in capacity. So you'll see in data sheets that various lithium batteries would say what the capabilities are on the entire battery. Some can discharge at 1C, others can discharge only continuous at half C. So those are all specs that comes from the lithium cell itself. But again, it comes at an expense, and knowing, is it more runtime you need? If you need a lot of runtime, maybe that C rating is not so important. But if you don't need a whole lot runtime, but you need a lot of high current discharging, then the higher C levels would be critical in this case.
Right. And just to add to what Jimmy just said, when you say lithium, people talk about it like lithium is just one generic type of battery. But within lithium, there's different flavors, formulations that you use. Some are better at delivering high discharge than others. But the trade-off to is if you have higher discharge, it comes with some safety concerns. So you might need a more robust BMS to ensure that you don't over discharge. Everybody's heard and seen all the YouTube videos about what happens to lithium batteries when they get over discharged or discharged too fast, and you don't want that situation. And typically the higher discharge lithium batteries are much more costly than the lower discharge regard. So getting back, you really got to nail down what your requirements are. You could get a 1C battery, but it could be cost prohibitive for your application.
It's a balancing act, kind of, right?
Yeah, 100%.
Okay. Okay. We've got about 4 minutes left and quite a few questions, so we're probably not going to get to all of them. Sorry, folks. But next question: the IC 650, 900, and 1200 opportunity charge rated for flooded and AGM. Can you charge during shift versus just at the end of one shift application?
Sure, I'll take this one. Yeah, definitely decide again based on how much time you have. We always recommend and promote having opportunity charging, simply because that keeps the batteries tend to like living in a higher charge state than a lower discharge state. Correct, Jimmy? In general,
Yeah,
right?
yeah. And then on the battery side, carbon is a big part of being able to operate in what we call partial state of operation, which is what just Paul was describing from the audience. And with carbon, with our products, we've been having it since the early beginnings. Carbon in the batteries will improve partial state of charge operation. And when coupled with the right charger and an optimized algorithm, yeah, for sure, partial state of charge, it's no problem. We generally recommend customers to just plug, if it's the right charger that's set up for it, to plug it in when not in use. It's easy for the operators to understand.
Right.
Okay. Next question. How much each of these chemistries, wet, gel, AGM, should be discharged, DOD, to get the best cycle life out of them? Many OEMs do not have cutoff features in their machines, resulting in shorter battery life.
You want to take this, battery guy?
Yeah, so if you look at DODs, you can see even in data sheets from all manufacturers that having a shallower DOD, let's say 50% DOD versus going down all the way to 100% or 80% is what most manufacturers recommend. You would get much more cycle life out of the battery under shallow DODs. But in the end, it's really about getting the job done rather than how or what the depth of discharge is that the manufacturers would like you to use the batteries at. So low voltage cutoffs, yes, it could be a potential problem if there isn't one, but there are batteries that are more robust than others. And there are batteries that are purpose built for motive applications where these type of situations are known. So it's not like it's bulletproof. It's not like it's RoboCop, but rather it's able to be more resilient and forgiving when being over discharged or drawn all the way down. So you have to really understand what batteries you decide to use, whether flooded, AGM, gel, even besides the chemistry, the different products, what it's purpose built for is important when selecting one.
Right. And one of the things I'd say in my experience is to make sure that you right size the size of the pack, because if you have a smaller battery, you tend to over discharge it more often than having a larger capacity. I mean, it's all dependent on your size. Maybe you don't have the space in the battery compartment to have a larger capacity battery, but right sizing and getting as well as getting the right chemistry is getting the right size of battery as well. So.
And adding on to that, the right size battery, that's a common one too. The right size battery is nice, but also having the right size charger. So we do see situations where people upgrade the battery to a higher capacity one, but they keep the charger the same. And then they find out they don't have enough charging time available to fully charge the battery. So in the end, they run into batteries constantly working under partial state of charge and never getting the full charge. Right. So understand how much time is available for charging. A larger capacity battery with the same charger will take you more time.
Correct.
Okay, just respecting everybody's time here. We're pretty much out of it, unfortunately. Some really great questions were submitted, and we have quite a few left. We won't be able to get to those, unfortunately, but you can connect with Hiroshi and Jimmy on LinkedIn. So pull out the phone again, or just copy down the email addresses, and you can submit your questions directly to either Jimmy or Hiroshi. Have those answered, and just connect with them on LinkedIn and build your network up. So again, please connect with Jimmy and Hiroshi on LinkedIn, and thank you very much. That's the end of our webinar. Yeah, terrific. Thanks, Jimmy. Thanks, Hiroshi. It was great, and we really do appreciate everyone taking time out of your busy day on behalf of Delta Q and Discover Battery Systems. We do thank you for joining us today, and wish you all the best. Enjoy the rest of your day. Thank you very much.
Thank you.